Hi, welcome to Zona Mechanica. There is a numerical answer type of question on collision of two elastic bodies. The figure at the margin indicates the weightage of the question, that is 1 mark. A small ball of mass 1 kg moving with a velocity of 12 meter per second. Suppose this is the small mass of 1 kg and it undergoes a direct central impact with a stationary ball of 2 kg. Suppose this is the stationary ball of 2 kg stationary, so initial velocity of this 2 kg mass is 0. The impact is perfectly elastic. The question is, what is the speed in meter per second of 2 kg mass ball after the impact? That is, if v1 is the velocity of small mass after the collision and v2 is that of the 2 kg mass ball, then what is the value of v2? This is the question. See, it is told that the impact is perfectly elastic. So what does it mean? It means the coefficient of restitution, that is E, is 1. We know the coefficient of restitution E is equal to 1 for a perfectly elastic collision or impact. What is the coefficient of restitution? That is relative velocity after collision to relative velocity before collision. The ratio between these two is the coefficient of restitution E, that is equal to 1, since it is a perfectly elastic collision. So from the notation taken here, we can write down that relative velocity after collision is v1 v2. So v2 minus v1 or v1 minus v2, you can take any one, by u1 minus u2 is equal to 1. See, you can take v1 minus v2 here. In that case, you have to take u2 minus u1 in reverse order, just for remembering purpose. I'm saying this. So if you can remember this formula with this notation, then well. If you get any confusion between this v1 v2 u1 u2, then just remember that if you take this upper side v1 minus v2 in this order, then just take in reverse order u2 minus u1, or v2 minus v1 then u1 minus u2. In either case, the result will be the same. Okay, so from here we are getting, we know u2 is equal to 0, okay, and u1 is equal to 12. So v2 minus v1 is equal to 12. Directly I am writing. Okay, so one equation we get on relation between v1 and v2. So v1 is unknown and v2 is also unknown. Okay, so now we know from the conservation of momentum, we have m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, right? So from here u2 is 0, so this is going 0. M1 is 1 kg and E1 is 12, so this is 12. This is equal to plus 0, this is equal to M1 is 1, V1 we don't know, so V1 plus M2 is 2 and V2. So from here we can write down that 2 V2 plus V1 is equal to 12. So writing this expression here just below this one for the simplicity, V2 minus V1 is equal to 12. So now adding both the equation, so 3 V2 and this is 0, okay, so is equal to 24. That implies V2 is equal to 8. Okay, so this is since this is a numerical answer type of question, the answer will be given in a range. So for this question the range of answer is 7.8 to 8.2. So our answer is 8, so it is within the range, so this is a correct answer. Okay.